Okay, today we're going to build the RFLAN software for the BytePipe SDK. Everything, all the documentation, and this video can be found on GitHub under NextGenRF's GitHub page, which is where we're at here. If you scroll down, we are looking at the RFLAN. You can click on that, and it talks about the real-time processor and the architecture of it. But if you scroll down to building source, there's directions that we're going to follow to build this software. We'll skip the programmable logic because we did that in a previous video. And right here, we will be building the RPU software. So as I mentioned, we did previously build the HDL. And if you watch that video, we downloaded the GitHub repository on our C drive, made a workspace folder which contains the RFLAN and the IP associated with the HDL. In the RFLAN project, the HDL is here, and the file that we're going to use to build the software is right here. Now you don't need to build the HDL from source in order to build the software. If you're a software guy and you only care about the software, you can build without any HDL. And to do that, I'm going to delete this workspace folder and start fresh. But you can build the HDL first and then build the software, and the process is the same. The only difference is this file is already here if we previously had built the HDL. If we don't build the HDL, then this file will be downloaded from the latest release on GitHub. So what I'm going to do is we'll delete this workspace folder. The workspace folder is just a folder so we've downloaded the BytePipe SDK code, and the workspace folder is just created in here because it's nice to put all of the build artifacts in a separate folder, and we can delete it like we just did. We don't lose any source code. All the source code remains in the source repository. So we're going to use Cygwin to build the software. And if you need information on setting up your host PC, you can click setting up build environment. There's a link in the documentation, and it runs you through a Linux setup or a Windows PC setup. It shows you where to get Cygwin and what toolboxes need to be installed as part of Cygwin. So I have installed all of those, and I have Cygwin here. And my folder is here. What I'm going to do is I'm going to change my directory to C drive. I'm going to make a directory called workspace. It can be anything you want. Like I said, I just like to use workspace. Now we're going to use Vitis from Xilinx to build this. So I'm going to search my previous commands. I need to export Vitis into the environment. You can set it up so it's always in your Cygwin environment, but I sometimes use different versions, so I like to do it each time I open Cygwin. I'll export that. That corresponds, so what we just did correspond to instructions here. Building source, clone, create a workspace, change to it, export the Cygwin path, and then we're just going to call one script here. One line will create all of the software. So we're going to paste that, and whoops, make -f. You need to go to the source folder, you need to go to RFLAN, make file, and software. So before I run that, let me open up workspace, there's nothing in workspace. So since we're building the RFLAN project, it's going to create a folder named RFLAN. And then inside that folder, it will create everything needed, all the projects associated with the RFLAN. Outside the RFLAN project will be some IP that's used inside the RFLAN, so that will also be downloaded. So I'll start by doing this. Okay, so I need to type in the device type, since there are multiple processors used on the BytePipe. The version I have is a 3CG. I'll type that in, and you will see inside the RFLAN it downloaded the hardware definition file from the latest release on GitHub. And you also noticed it was downloading the ADRV 9001 SDK from Analog Devices. This link can be found in the makefile, or it's also in the documentation. But this folder contains much of the source. Well, here, it just unzipped it so we can go inside and look. It has the prototype evaluation, production folders. Evaluation includes the transceiver evaluation software that you can install on your device, on your PC. We are using the production C-source software in the RFLAN, and this will be the RPU project. The software project will reference this folder right here, portions of it. So we go back to workspace. It exported those, and now it is building the software. So right now it's using Vitis to create the project. If we go into RFLAN, it's actually creating the hardware platform based on the exported programmable logic. So that's what it's doing now. The hardware platform includes all the board support packages, lightweight IP, FreeRTOS, and so forth. Software usually doesn't take more than a couple minutes, 2 or 3 minutes to build. Okay, so it finished building the libraries or the hardware platform. I believe it's just exporting it, and now it's going to build the RPU and the RPU system. The RPU is the project containing the source code that will be programmed onto the real-time processor, and it's the RFLAN project. The system allows us to create a first stage bootloader and boot.bin to go along with the RFLAN. So this will continue building. This will probably take another minute or so. Okay, it has now finished. It has built successfully. I know that because the SD card was exported. And in this SD card folder includes the boot.bin, which is the first stage bootloader, and the RFLAN code. And then some files that are useful on the SD card are included in this folder. So you can copy all these directly to the SD card, put it in the device, and turn the device on, and it will boot up and run the RFLAN code. The next thing we can do is we can launch Vitis. I have Vitis here, 2021.1. We'll switch workspace to the RFLAN folder. And that'll just take a moment to come up. Okay, we've switched workspaces, and you can see we have the RPU system and the RPU project, and we have all the source code. Now, a lot of these links are virtual links, so the source code itself, it has not been imported into the workspace folder. If you go into the RPU source folder, there's very little in here, except for what was downloaded as IP. There is some of that, but most of these are links. You can read through the code, compile the code. The code should have been compiled already. It's not a bad idea when you do this to clean the RPU and then build all, even though it already did it, but never a bad idea. And then to debug, I will turn on my device, which I do have hooked up through JTAG. And if you're familiar with Vitis, you can debug a couple different ways. You can debug with or without the SD card in there, or you can debug with or without the first stage bootloader process. I'll show you what I mean here in a second once this is done building. What I do is I do debug as. Well, it's waiting to build before it will give me an option. Okay, debug as. I guess it's not coming up. Oh, there it is. Launch, I select the first one, launch on hardware. Now what I like to do is immediately go down and cancel this launch, because then I go to debug configurations, and I don't like to debug with the first stage bootloader in there, so I just shut that off. Right now I have the SD card out of the device. I'm going to start debugging. You will want to put the SD card back in once you are ready to start executing code. The reason I pull it out at the beginning is because otherwise it confuses the device, the debugger, thinking it should be, for some reason it thinks it should access code on the Cortex A53, which is down here, but we want to do the RPU. If you leave the SD card in, it will default you to the A53. All you have to do is come up here and select this processor, and you'll see the breakpoint here. So now I'm going to insert my SD card, and I am going to open up TerraTerm, which we do have another video on how to access the CLI. So I'm going to just open up this quick, 115.200, and once I hit go, there's our code executing. So now you can put breakpoints wherever you want. You can see it just went through and initialized everything. One thing I will mention is on the SD card, there are some scripts. RFLAN setup, ADRV setup. The RFLAN setup runs up here before it gets fully through boot up, and you can put in RFLAN, or excuse me, CLI commands, any CLI commands you want in these scripts, and it will execute them. So if I want to disable lightweight IP, for example, or change my IP address, I can put those in here. This isn't the one on my SD card. It looks like I have lightweight IP enabled on my SD card, but in this example, it's disabled. So you can put those in there. You can put anything you want in the ADRV. Generally, they're ADRV parameters, but they don't have to be. For example, I'm just setting the attenuation to 10 dB here. So those are important if you want to change a configuration. Now, of course, you can execute those commands later, um, but there'll be more on that when you watch the CLI video. So that concludes building of the RPU software for the RFLAN. Thank you.